we need to find out the value of the given expression. So here we have 0.16 raised to the power of log with a base of 2.5 of this given infinite series. So we'll step by step. First, let us begin by computing the infinite series. So here we have 1/3. This is added to 1/3 squared plus 1/3 cubed, and this goes all the way up to infinity. Now this is a geometric series. That's because if we consider the first term to be 1/3, the A represents our first term. Then we have a common ratio. Now the common ratio can be obtained by taking any term dividing by its previous term. So that means if we take the second term, so our second term, and divided by the first term, that will give us the common ratio R. So let's find it out. So we have 1/3 squared divided by 1/3. So that's equals to 1/3. Similarly, if we can take the third term and divide it by the second term, which will be 1/3 cubed divided by 1/3 squared. So this gives us 1/3. So that means we have a common ratio of 1/3. And the sum of the infinite series for a if it is geometric, then this is given by A divided by 1 minus R, provided R is less than 1. Right. So that means here our A value is 1/3 and we have 1 minus R value is 1/3 as well. So we have 1/3 divided by 2/3, which is equals to 1/2. That means the sum of this geometric series is 1/2. So we can reduce this sum or sum of the infinite series with the value half. So that means our expression then becomes 0.16 raised to the power of log with a base of 2.5. Now the sum reduces to 1/2. Now how do we find out the value? For this, we have to use a property. Let's say if we have A raised to the power of log of B with the base of A, then this becomes equals to B when we have the base of the exponent and the base of the logarithm are exactly the same. But in our case, the base of the exponent is 0.16 and the base of the logarithm is 2.5. So that means we need to find a relation between them which makes them exactly equal. So how do we do it? So this is going to be our step number 2. Let's do that. Now we know that as we have 0.16. So 0.16 is 0.4 squared. So when we square 0.4, we should get 0.16. Now 0.4, this is also 2/5 in the rational form. So we have 2/5, or we can say 5/2. That means we take the reciprocal and the power will become -2. Now what's 5/2? So 5/2 is 2.5 raised to the power of -2. So we found out the relationship. That means if we have 0.16, this is the same as 2.5 raised to the power of -2. That means our expression now becomes 2.5 raised to the power of -2, and this whole thing is raised to the power of log of 1/2 the base of 2.5. That means we have 2.5 raised to the power of, so the exponents will get multiplied. So we have -2 multiplied to log of 1/2 with a base of 2.5. Now we need to get rid of this coefficient of logarithm, because here the coefficient is 1. So we will use another property of logarithm that says that if we have A times log of B, this is the same as log of B raised to the power of A. That means we will now have 2.5 raised to the power of log of, we have half, but now half will be raised to the power of -2, and we have a base of 2.5. So here we have seen that the base of the exponent is 2.5 and the base of the logarithm is 2.5. They're exactly the same. We can use this particular property, and this reduces to 1/2 raised to the power of -2. So 1/2 raised to the power of -2 is, that means we have 2 raised to the power of -1 raised to the power of -2. We can multiply the exponents over 2 times -1 times -2. So that's simply 2 +2, and 2 squared is 4. That means our final value 0.16 raised to the power of log with a base of 2.5 of the infinite geometric series 1/3 plus 1/3 squared plus 1/3 cubed all the way up to infinity. So this value is equals to 4. So this is the final value of a given expression.